Hello everyone, welcome to Civil Engineering and Stuff. And in today's video lecture, we are going to do a numerical on Lacey's theory for regime channel. Now, regarding the Lacey's theory, we have discussed in detail about the Lacey's theory, the various regime conditions that Lacey proposed, that is the initial regime, true regime, and the final regime. We have also discussed in the previous video lectures about the design steps that the Lacey's gave, and then we had compared the Lacey's theory with the Kennedy's theory, and we discussed how Lacey's theory was superior than the Kennedy's theory. So all these things we have discussed in the previous lecture. So if you haven't watched that lecture, I'll recommend to you to go and watch that lecture. Now, about the Kennedy's theory, we have again made a series, and we have discussed in previous lectures regarding the Kennedy's theory. And then we have discussed the two numericals on the Kennedy's theory. So again, if you haven't watched those lectures, you can watch the lecture regarding the Kennedy's theory. In this video lecture, we are going to do a numerical on the Lacey's theory. Now, the question that we are going to do today is that we have to design a regime channel for a discharge of 50 cubic and a silt factor of 1.1 using Lacey's theory. That's the question that we are going to do today. And you will observe that unlike Kennedy, the Lacey's theory or the design of regime channel through Lacey's theory is a much simpler. Reason being, like, you have to simply follow the steps and you will get the values and you will basically get the all the parameters. Unlike Kennedy's, where we had to assume a certain trial depth and then we have to find out the critical velocity, then we have to follow certain steps, then we have to find out the actual velocity and see if critical velocity is equals to the actual velocity. If not, then again we have to assume a new trial depth and likewise. So unlike that, Lacey's design of regime channel is a very straightforward methodology. So let's solve this question using Lacey's design of regime channel. All right. So first of all, what are the given parameters to us? We'll write down the what are the given parameters to us. We have the discharge value of 50 cubic. We have the discharge value of 50 cubic, and we have the silt factor value of 1.1. Okay. Now, straightforward, we'll move to the design steps, and the first step that we know, we have discussed previously, that the first step is to find out the velocity. And as discussed in the previous lecture, Lacey himself gave a formula to find out the velocity of the flow in the regime channel. And the formula was V equals to QF square by 140 to power 1 by 6. So the value of Q, we already know. So like I always say, keep a calculator and notebook with you, and as we move along, do solve the numerical and see if you are getting the same value as I am, and if the values are different, just see like if I'm doing the wrong calculation or is it from your side. Okay, so now the velocity that will come out is 0.87 meter per second. Okay, 0.87 meter per second. So that is the velocity through Lacey's formula, and that's the end of step one. Now we'll move to step two. What was step two? The step two was to find out the area. Step two was to find out the area, that is through simple formula A equals to Q by V, and Q we have been given in the question as 50. V we have found out in step one, that is 0.87. So through this, just solve it and see what is the value that is coming. The value will come out to be 57.50 unit meter square. Very important to write down units. Okay, don't forget to write down the units. Okay, so this is the area that we get. Then the next step is to find out the step three. The step three is to find out the hydraulic mean depth. Hydraulic mean depth R, whose formula was again given by Lacey. R equals to 5 by 2 V square by F. Alright, R equals to 5 by 2 V square by F. So 5 by 2, what is the value of V? The value of V we have already found out in this step 1, that is 0.87 whole square. F we have been given 1.1. So through this, the value of R that will come out to be is 1.72. What is the unit? The unit is meter. Okay, I hope you are also solving as I move along. Okay, you can pause the video, solve the question, solve the values by yourself, and see if you're getting the same values. Okay. Then after that we move to step 4. Step 4. What is the step 4? Step 4 is to find out the parameter of the regime channel section. Now for this, the parameter formula was again given by Lacey himself, that is 4.75 under root of Q. Okay, so 4.75, Q is 50. So the value that will come out to be is 33.59 meter. 33.59 meter. All right. So the next step in the Lacey theory of regime channel is to find out the width of the channel section and the depth of the channel section. So first of all, we'll just clarify that we are designing a trapezoidal channel section. For a trapezoidal for a trapezoidal channel section, we are designing a trapezoidal channel section that have the side slope of half horizontal is to 1 vertical. Since this value is not given to us, this is what we are assuming. Okay, so we are designing a trapezoidal channel section that is having a side slope of half horizontal is to 1 vertical. So the area of the trapezoidal channel section will be A is equals to B plus ny into y, where y is the depth of flow, and b is the width of the channel section. Width of the channel section. All right. Now the value of area we have already find out in step 2, 57.50. So we'll put simply here 57.50. 57.50 is equals to B. N is the side slope value, that is half into y into y. All right. Next, since we have to find out the width value and depth value. All right, because we are designing a channel section. Okay, understand that what we are doing, we are designing a regime channel section. Now, for the design of regime channel section that carries a discharge of 50 qmax, what do we need? We have specified the velocity with which the water should flow in that channel section. What should be the area we have specified? What is the hydraulic mean depth we have specified? What is the parameter we have specified? Now what remains? Next we have is in that channel section, what should be the depth of flow as well as what should be the width. That is also we are going to tell, and after that we are going to tell what is the bed slope. All right, so that's why we are now finding out the b and y value. So in line of that, first of all, we have used the formula for area. Okay, so this is our equation 1. Now you see we have two unknowns, so we need another equation to find out the value of b and y. So now we have the area. Next, we can use the parameter. So if you see in a trapezoidal section where we have the water that is flowing at a depth y that has side slope as n is to 1. So in this case, simple, if this is the width, then this is how much? This is ny. So this will be under root ny square plus y square. Simple trigonometry. Okay, use of Pythagoras theorem. This is the side slope or the weighted parameter, and like this we have 2. So parameter P, parameter P will be equals to B plus 2 into n y square plus y square. In this case, n is half, so we can write b plus 2 into under root half into y whole square plus y square. I'm just solving it just in case like sometimes student get confused like how this value came. So I'm just deducing this expression how this value came. So on and all it will be 2 by 2 into y under root 1 plus 2 square. So b plus under root of 5 into y. Correct? So the parameter value is 33.59. Parameter value is 33.59 is equals to b plus y root 5. All right. So just in case if let's say in the question it was given that we have this side slope as 1 by 4 horizontal is to 1 vertical. Just in case, then here n would have been this n would have been 1 by 4. This value would have been 1 by 4. Okay, this n value would have been 1 by 4. All right. So it's very important to know how this formula came. It's very basic fundamental things. So this is our equation 2. This is our equation number 2. Now, so what we can do is we, we can put the value of b from equation number 2 in equation number 1. So here b is equals to 33.59 minus y root 5. Okay, so let's say this is equation number 3. So putting the value of b from equation 3 in equation 1, from equation 3 in equation 1. So let's just put the values in this equation. So if you put the values in this equation, we'll have 57.50 is equals to it is equals to the value of b will put 33.59 minus y root 5 plus n is half into y, then multiply by y. Okay, so now you can see here from here we'll get an quadratic equation for y. So the equation that will come out to be is 1.74 y square minus 33.59y plus 57.50. 57.50 is equals to 0. That is the quadratic equation in terms of depth y that we get. Now if you are using 991 ms calculator, I have already prepared a video lecture as to how we can use the functions given in 991 ms calculator to solve this 2-degree equation. All right, so using the 991 ms calculator, if you put the values, the value of y that you will get is 17.41 meter and 1.90 meter. Okay, so definitely which value we are going to choose? We are going to choose 1.90 meter because eventually, like this is oversafe. Having like both the depth will do the same function, correct? So why not go for a depth that is comparatively lesser than the other parameter? Okay, choose if we choose this depth, then it becomes kind of like uneconomical approach. Okay, while this is an economical approach, so that's why we are going to take 1.90 meter. So using this, if we put the value of y in equation 3, if we put the value of y in equation number 3, the value of b, the value of b that we will get will be 29.33 meters. Okay, 29.33 meters. So like this, now what we have find out the depth as well as width of the channel section also. Now the only thing that is remaining, this was step number 4. The only thing, the only thing that is remaining is to find out the bed slope. The bed slope S. And again, Kennedy, unlike Kennedy, Lacey gave the formula for finding out the bed slope value. So Lacey himself gave the formula to find out the bed slope value, that is S equals to F to the power 5 by 3 by 3340 q to the power 1 by 6. So just put the values. We'll have 1.1 to the power 5 by 3 divided by 3340 into 50 to the power 1 by 6. So this will be 1.17 divided by 6410.74. So we can just write 1 divided by 6410.74 divided by 1.17. So this will come out to be 5469.16. This is the bed slope value. Okay, so this is the bed slope value that we are going to get. So using Lacey's theory, basically we have find out all the parameters for the regime channel that should carry a discharge of 50 cubic and has a self factor of 1.1. If you see, we have find out the velocity with which the water should flow, then what will be the area, what will be the bedded parameter, what will be the width, what will be the depth, as well as the bed slope of the channel. So all the parameters we have found. Now, if you compare it with the Kennedy's design step for the regime channel, you can see how easy it is to construct the regime channel through Lacey's theory with respect to the Kennedy's theory. Okay, so one more important thing to note for the Lacey's topic is that you should remember this formula thoroughly. Okay, you should remember the formula thoroughly because in many of the competitive exams, question comes directly from the formula itself. So they may give you simply the discharge value as well as tilt factor, and then you have to find out the velocity. Okay, likewise, it may happen that they give you the diameter of the particle, the discharge value. Then again, they may ask you to give the velocity. So you can simply using the tilt factor formula, you can first of all find out the tilt factor and then find out the velocity. Likewise, they can ask the hydraulic mean depth, they can ask the parameter, they can ask the bed slope. Okay, so all the formulas should be, you should know thoroughly. And then the source of mistake in Lacey's is the calculation. That's the only after you have remembered the formulas correctly, the next source of error that comes out is that maybe due to time constraint, maybe due to lack of practice, calculation error may take place, especially during this B and Y finding and finding the bed slope value. Okay, so these are the two, three reasons in which you can do the mistake in Lacey theory. First of all, not remembering the formula correctly. Second, calculation error, either maybe due to time constraint or due to lack of practice. So practice very well. Okay, solve the values through calculator and see if you're getting the values correctly or not. Okay, so that's all for Lacey's theory. I hope the lecture was useful to you. If so, like the video and do share your views in the comment section. Okay, was the video helpful, not helpful, what improvement can be done? If there is any topic in which you want me to make videos, do tell me. Okay, and that's all for this. Thank you for watching. Subscribe to the channel for more videos like this and press the bell icon for the regular notification. Thank you for watching. Have a nice day.